Hello everyone, my name is Alex and I'm going to be your host for this part of the presentation. We're going to discuss about Thomas-Young experiment and the single-slit diffraction. We already learned that light is an electromagnetic wave formed by oscillation of electric and magnetic fields. Before we talk about the single-slit research performed by the famous scientist Thomas Young, I just wanted to discuss briefly regarding the double-slit experiment. An experiment of using a beam of light passing through a double slit was made, and the scientists initially thought the light would produce a single spot of brightness. However, when this experiment was performed, the result was that multiple bright spots were produced. They discovered that when the light passes through a double slit, the light does not produce uniform brightness. Instead, it produces an alternating of bright and dark between multiple spots. It is known as the diffraction model. This model is created when the wavelights interference with each other, creating a constructive or destructive interference. After this little intro, we can talk about how the single-slit diffraction works. Likewise, light shone through a single slit also have a diffraction model. This means the brightness of the light alternate between bright and dark spots. There are two major differences between a single slit and a double slit that I'm going to point out. The first major difference is the central bright spot. For double slit, the thickness of each spot is the same as the other, but for a single slit, a central bright spot is twice as wide of the other bright spots, meaning bigger. So this model can be observed only for the central spot. All the other spots will have a uniform size. Like in a double slit, the diffraction model is produced due to the interference. The second major difference between a single slit and a double slit is that for double slit, you have two sources of light interfering with each other. And for a single slit, you have just one source of light. This means that the light leaving from the top of the slit and the light leaving from the bottom of the slit does not have the same angle. When the light waves arrive on the screen in phase, these waves you have peaks. When both waves have peaks, it will produce a constructive interference or a bright spot. The amplitude of the light wave increases under constructive interference, so higher wave amplitude produces brighter spots. When the light waves arrive on the screen out of phase, the waves you have a peak and a trough. When this situation happens, a destructive interference or a dark spot is created. The amplitude of the light wave decreases under destructive interference, so lower wave amplitude produces darker spots. Light spots are actually called fringes. For single-slit problems, we have just one equation that gives us the location of these dark fringes. The equation is defined as sine of theta is equal to m lambda divided by d, where m is the index number for different angles, and d is the distance between the top and the bottom slit. Well, this covered the discussion about Young's experiment and the single-slit diffraction. The next host will be continuing with this presentation. Thank you.